Dear students, in this video I am going to explain about virtual functions. So before understanding the concept of virtual function, already you have discussed about virtual class. So this is different concept, virtual functions. So this virtual function coming under the concept of polymorphism. So before understanding this virtual function, we have to learn about some important topics. After completing that topics, I will explain what is virtual function. So this is coming under polymorphism. Polymorphism nothing but one name and multiple form, which consists of only one name but multiple form. So under this category, we have discussed so many concepts like overloaded function and overloading operators, overloaded functions and overloaded operators. So you know about overloaded function and overloaded operators. So overloaded function means it consists of so many data types, different data types or different number of arguments, but in the same name. That is only one name, but it is in multiple form. It consists of different number of arguments which are in different type, but the name, same name. For example, add int, comma, float, add int, comma, float. So this is coming under polymorphism. So in this overloaded function, or we have discussed about overloaded operators. The plus can be overloaded. The plus can be used for the objects. So what we have discussed in overloaded operator. So all these will happen during compile time. So while the compilation, the compiler identifies this syntax and matches while calling the function. While calling the function, the compiler identifies this function and matches and invoke this statement. While during the compilation time, during the function call, the compiler calls this function and invoke all these statements under this. Similarly, during the function call of this one, the compiler identifies this, differentiate under the three category and identify the correct one and invoke the statement. So this will happen during the compilation time. That is called as early binding or early binding or static binding or static linking. This is called as compile time polymorphism. So object is bounded to its function during call at compile time. So during the compilation time, the object is combined with the function. For the object, we are calling the function. So it identifies the correct function and then it invokes everything. This will happen during compile time. So during compile time. So this category is called as compile time polymorphism, which has one name and which are in different form. This is called as compile time polymorphism. During compilation, it bounds all the functions with the object. This is compile time polymorphism. So overloaded function and overloaded operators are all coming under this category. This is called as yearly binding. This is called as yearly binding. So yearly binding nothing but during the compilation time it invokes everything. That is yearly binding or static binding or static linking. So linking the member function with the objects. That's why static linking or static binding. And another one category is available, that is late binding and dynamic binding. Late binding or dynamic binding. This is called as, so late binding or dynamic binding is the concept is used here in virtual function. So the virtual function is coming under late binding or dynamic binding. Another one name is runtime polymorphism. This is runtime polymorphism. That is, function is linked with a particular class much later after the compilation. So the member function is linked with the object after the compilation time. So here it is called as late binding. So here we are going to use the pointer concept. Whenever we are using the pointer, During the compilation time, compiler will not allocate the memory space. Only during the runtime, runtime, the memory will be allotted. So that is called as runtime polymorphism. Pointers to objects. So previously we have created a pointer for a single variable or array of variables. Here we are creating the pointer to the object. So very simple. That object address is stored in a pointer variable. That's all. Object address is stored in a pointer variable. That's all. So see this example. Class item. This is a class. Class name is item. So automatically the item is a class. Then you are creating object. So whenever you are creating the object, the memory space is allocated. So item x. So now x is object and item, that means it's a class. So user defined data type. Now consider this data type. So item is a data type, but it is coming under user defined data type. Remember, the data type is item and object. This is object. Whenever the object is created, automatically the memory space is allocated. See here, memory space is allocated for the object x. So it has one address. In this address, it consists of data members for x. For example, inside it consists of data member xy, means allot the memory space x and y. Then it allots the memory space for member function. So it has some starting address. So based on this, the address will be incremented. It has one starting address. Okay. So object x. So the x has one address. Example, I have given 0 cross 154. Object s, it has the address, starting address. This is a starting address. Based on the number of data members, member function, the address will be incremented. Okay. Pointers for the object x. Now we want to create the pointer for the object. In the previous programs, only you have created item x. So if you want to create one pointer variable, just you have to include the syntax. This syntax already I explained. Data type, dereference operator, pointer variable. So remember, whenever you are using the pointer, you have to declare that I am going to use the pointer in my program. Data type, dereference operator, pointer variable. So here, what is the data type? So data type, nothing but item. So item, dereference operator, I have to use pointer variable. Any name you can give. Whatever you are giving next to your different reference operator, that is considered as pointer variable. It's not necessary to give always PTR. You can give a or any value you can give. Okay. So this is object pointer. This is called as object pointer. It's created the memory at run. So whenever you are using the pointer, you should understand that memory is allocated during the runtime, not in the compile time. So compile time, nothing but connecting your source code with all the libraries. Here runtime, nothing but it running the coding. So for each and everything, it takes the value, it starts its operation, mathematical operation. That is runtime. Okay. So this is your object pointer. So previously, why it is called as object pointer means, see here, this is your user defined data type. This is your user defined data type. That's why it is called as object pointer. There is no other difference, only the data type. So normally a pointer is created like this, PTR. So everything is same, only one difference is this is inbuilt, this is user defined data type. That's why it is called as object pointer. Okay. So using object pointer, public members can be accessed. Through this pointers, you can able to access your member functions. So public members means member functions you can create. So item x, item dereference operator, PTR is equal to address of x. So normally you are doing this, you are allocating the address to this pointer. So item dereference operator, PTR, nothing but it takes the value from this address. So consider the value from this address and address of x. So this is the object. So object starting address. See here, object starting address is assigned to PTR. So object starting address is assigned to PTR, and then dereference operator takes a value from this PTR. Correct? So this is way, in this way you have to access your data members and member functions. So you are allocating the memory. Then how you are going to access your member functions? In two ways you can able to access. Normally without pointer, how you can access? X dot get data, x dot show data. So normal way, this is normal way what you are using in all the previous programs. So x dot get data, x dot show data. But now you are using pointer, so you can use this syntax to call your member functions. That means through the address you are calling, so the address consists of the PTR pointer variable consists of address of your object. So what is the address of your object? 0 cross 155, correct? So PTR is a pointer variable which consists of address of your object. So what is your object? X. What is the address? 0 cross 155. So through this address you are calling a member function. That's why you have to give like this PTR, this symbol, the arrow mark, get data, PTR, and this arrow mark, and show this function. Okay, so these are the two methods how you can access. A normal way you can access like this. If you want to access through your pointer, you have to use this syntax. This is another syntax to call your member function. See here, dereference operator PTR. That means value inside the address. So value inside the address. So value inside the address means that is the object. Value inside the address means object x. Okay. For this object you are calling this member function. This address you are calling member function. So I explained three syntaxes. One is x dot show. This is just using object. Otherwise you can use PTR show. That means the address, for this address you are calling. So what is the content in this address? The content in that address is x. So PTR represents only address. What is the value inside the address? That is the object. So for this object you are calling. This is another one syntax. And this is one more syntax. Directly the value inside the address. Correct? The value inside the address. For this you are calling member function. There are three syntaxes. So one is normal one, another one using your pointer. Okay, so whenever you are using the pointer, it will do everything during runtime. And for this you can able to create the memory space during runtime using new operator. So what is the syntax? Data type PTR, that is dereference operator PTR, that is equal to new item, new data type. This is why you are using this data type. So for normal thing, how you will do? Int PTR is equal to new int. So what is this? Int is a data type. This is also data type, and this is the value present in the address. Similarly, for your user defined data type, item data type, this is the value which is present inside the address. That is here. This is object, and you are creating a memory space, enough memory space for the data type item to store the user defined data type. Okay, it allocates enough memory for the data members and assigns the address of the memory space to PTR. That's all. So PTR show, and for example, if you are going to use array, you have to use this one. You have to just include how many numbers you are going to use, how many arrays you are going to use. The size is given like this. Hope you understood this. The next video we will discuss about this pointer.